You want to know what kind of top speed you can get out of a given piece of machinery? And it doesn't just apply to bicycles, it also works for motorcycles, cars, trucks, ATVs, whatever you're working on, because the math is the same. On a bicycle, these sprockets is your transmission, and whether you have sprockets, a light gauge like this on a bicycle, or heavier gauge like this on a motorcycle, or heavier gauge chain, or shaft drive, or whether you have, instead of sprockets, you have gears, it doesn't make a difference in math. It's the same calculation. So in this video, I'll show you how to calculate your top speed of your vehicle so you can compare different designs and see what the changes to that design actually accomplish. So you can take the guesswork out of your life and get more going done. The calculation is fairly straightforward. It's a bunch of multiplication and division. The idea starts here on this bicycle, and I'm going to cover the basics with it. Consequently, in the following videos with actual gearbox calculations, I'm not going to repeat the basics. So this is it. Watch it for 10 minutes. You'll, it's going to make a lot of sense when you watch the gearbox calculations. It's important to notice that on a bicycle, how the transmission works, it's important to realize how the crank relates to the wheel. Just as you have a crank shaft on an internal combustion engine, you have a crank on a bicycle the same way, and the rotations on the crank produce rotation on the wheel. That rotation on the wheel is what propels the vehicle forward. Okay, the relation between the rotation of the crank and the rotation on the wheel is very strictly mathematical. I'm going to take the mystery out of this one in a sec. Let me just get started on the rear wheel here. I'm just going to take it off the mount here. What I did with this rear wheel here is I put tape on it, and I went all the way around because we have to start with the circumference of the wheel. Where the tape ended, I made a nice black line. Why do we need the circumference of the wheel? We need it, let me just put you down here. We need it because it is a set mathematical ratio that produces one rotation on the wheel in relation to one or whatever amount of rotation on the crankshaft. If I start with the valve stem in the vertical position down there where the ground would be, and I also start with the crankshaft, or crank, sorry, the crank in a vertical position, you can see that as I turn around the crank a quarter times, the valve stem also turns around a quarter times. If I turn the crank half a turn around, we started down here, you see that the valve stem also went around once, half time, and when I go around once, a full turn, just about like so, you see that the valve stem ended up in exactly the same position. And in this situation, and you know it from my other video, let's go faster by changing sprockets, that the sprocket combination on this bicycle is such that I selected the one with the most amount of teeth for the rear and the one with the fewest number of teeth for the front to get the bicycle a transmission ratio that makes the bicycle the slowest. So this is as slow as it can go. And why I have this masking wheel on it, like I said, this distance should be and can be measured. Let me just take it off. Just give me a sec. Thereabouts. You see, this is a set length, and if you don't curl it up and don't stick it to yourself too much, you can get a measurement on it. Once it's nice and straight on the floor, You can measure its length, find the end mark, find the finish mark, and measure it with a tape measure. I measured this one already in millimeters, and the circumference of the wheel is exactly 2050 millimeters on this one. What that means is that every time you turn around the crank once, the vehicle travels forward exactly 2005 millimeters. That's 2 meters and a little bit. Okay, we'll go for 2 meters for now, just to visualize it. Okay, every time you turn around the crank once, the vehicle travels forward exactly 2 meters there. And that ratio is important. Consequently, if you change this wheel, to a smaller wheel with a smaller circumference, every time you turn around the crank, the vehicle will cover less of a distance. So changing your wheel and changing your tire to a smaller one is not going to help you to reach maximum speed, okay? The maximum speed here is limited between the cross members here, braces inside the frame, and there the wheel is going to reach the frame there. But you get the idea. If you get bigger wheels and bigger tires, it is mathematically gonna increase your top speed. Other factors about wheel and tire is coming up later. Okay, so we'll just do the basics here first. So that's the wheel. The next important thing that we need a measurement on is how fast can you turn this crank around. You know, I'm just gonna turn it the other way around now, so the wheel is not spinning. So how fast in a minute can you turn the pedal around? If you can do 1 turn in a second at about this rate, about so, that's about 1 turn a second. We're doing 60 of these turns in a minute. 60 turns in a minute means 60 revolutions in a minute, or 60 revolutions per minute, 60 RPM. Okay, that makes sense? This is the second measurement that we need, and it doesn't much change. If your top speed, if your leg's top speed is 60 RPM, it's going to be going the other way around, but you get it. If your legs can do 60 RPM, that is your input speed here on the crank here. Now, I went around with this bicycle, and in its lowest gear, where it's the easiest to pedal, I pedaled around as fast as I could, and my measurement was, my best in a minute was 128 RPM, but I can't maintain it. So 120 RPM, 120 times your knee, just your one, not both alternating, just the one knee. Say pick your left or pick your right, whichever you like. My knee goes up and down 120 times a minute, and that was my really top. I couldn't really maintain it for long. Either I'm unfit or it's just a fact. If you want to calculate with 100, that's also good, but you have to take a measurement on this one on your own. How fast can you pedal? And it's going to directly relate to your engine RPM as well. Okay, so it's important that you see this connection. So we've got the wheel, we've got the engine RPM, and these sprockets I already covered in a previous video. Like I said, let's go faster by changing sprockets. So come on over here to the table where I've got my paper here set up, and we can do this really fast. Okay. What I have here is one more thing about the wheel. This is the wheel, is a perfect circle as is, but if you put it on the road, it's gonna have a small contact patch on the wheel. That means that this wheel is gonna be flattening a little bit. Plus, if you sit on the bicycle or motorcycle or what have you, the driven wheel will flatten, the tire will flatten even more. Depending on how stiff the sidewall of the tire is, and whatever tire you have, it's gonna be flat a little bit. Not like you have a flat tire, but you know what I mean, just a contact patch. Now I'm gonna massively exaggerate here and say that's your contact patch. So the wheel actually goes a circular shape all around here, comes here and goes flat, changes to a flat shape here. So this is not on it. This is your contact patch here. It's massively exaggerated and out of proportion, but you can calculate it. Once you have a circumference, you can calculate the radius of your wheel, and you make your right angle triangle. You can calculate this length here, and you can calculate that length there. Okay, it's the full circle is not gonna be a lot longer than the partial circle with the contact patch. There's gonna be just 1 or 2 millimeters of difference. If you like math, go for it. Calculate this part of the wheel if you like. It's really hard to measure it. Okay, so that's the wheel, and this is where we are. So the factors that we need for this calculation is the number of teeth on the front sprocket, the number of teeth on the rear sprocket, the wheel, and your RPM. Out of it we're gonna make eventually kilometer per hour. A couple of things that I want to mention before this calculation gets out of control here. Factors in reaching maximum speed. Right now we're calculating the transmission ratio, but there are other factors, and let me do 10 seconds of language here what I mean by the word factor. Say 5 times 3 is 15, times 2 is 30. 5, 3 and 2 are factors of 30. Okay. There are other factors of 30. 1 is also a factor of 30. 1 is a factor of everything. It's an obvious. So likewise, in your factors, in reaching your max speed, that's what I mean, and that's how I use the word factor. Some of these factors will be obvious, like the 1 is an obvious factor of 30. So I'm not trying to insult your intelligence, just making this one clear. So we're on the same page, okay? So we're doing now is the transmission ratio. What I'm gonna ignore, but is also a factor, is the weight of the bike itself and the weight of the rider. If you have a tank ass, it's gonna be accelerating slower and reaching less of a maximum speed than if you are lean and mean. You get the idea, because it takes more force to accelerate. It takes more force to accelerate more mass. We know this from Mr. Newton. I'm also going to ignore friction, and there's different levels of friction. There is friction with air resistance or wind resistance. There is friction inside the axles for the crankshaft and the axles on. So I'm gonna spend time on it. If your chain is not lubricated well enough, it's gonna be a problem. The road surface, the interaction between the tire and the quality of road surface, it's a source of friction. I'm not gonna deal with it. Another factor is rigidity of the frame. If your frame bends, say made out of carbon steel, and it bends and flexes and absorbs bumps and everything, it's a nice shock absorbing feature, but it's also absorbing some of the force you're trying to put on your crank, on your pedal, and it's gonna be lessening. A soft frame will be lessening your top speed. Not by a lot, but everything is a factor, okay? Some factors are little, some factors are big, okay? Wheel, the same, the wheel material, not only the I'm not talking about the wheel size, I'm talking about the wheel material. If it's a softer alloy and it has some flex or bounce, the spokes have some flex in them. How rigid the spokes are affects your top speed. On a smaller wheel, spokes can be stiffer. On a larger wheel, spokes can have more flex of the same spoke material, okay, and of the same diameter or size. The tire wall, the stiffness in the tire wall also absorbs some of the force you're trying to put into going forward. And lastly, the suspension. Your bicycle may not have a suspension, but the frame flexes and the front forks are bent on a purpose. they have a curvature. This is what I mean by curvature. They have a curvature that's supposed to absorb, and it does absorb, it bends and absorbs some of the shocks. So that's also a factor. And I'm not gonna quantify any of these. Oh, I forgot the grade. If you're going uphill or downhill, it's a big factor in reaching top speed. Ignore this. We're dealing with only the transmission ratio, so you can compare different designs, okay? And this is what we're doing, and this is how we do it. The number of teeth on the front, I counted them. That's why I have this cute little pink crayon here. I just take it away from the kids. Number of teeth on the front is 28 when it's on the slowest. That's what that S stands for, slowest transmission. It's got to be divided by those are the drive sprockets, and these are the driven sprockets. Okay, I can just drive, and these are driven. It also works that way. Actually, it has to be that way. It can't be the other way around. Okay, so don't switch these around. This is critical that the drive goes first and the driven after. The driven number of teeth for the slowest transmission is also happens to be 28 on this particular bicycle. That's why you notice the phenomenon when the valve stem goes around exactly once on the wheel. That's when the pedal goes around exactly once in the lowest transmission ratio. It's a 1-to-1 ratio on this bicycle. And the wheel size was 2.05 for this wheel. That's in meters. It's important. Yeah, don't forget, people. Okay, it works with inches, and out of inches we're gonna work with RPM, and you can make miles per hour eventually if you like. I'm gonna work with meters, and we're gonna make kilometers out of it. Okay, but the math is the same. You just you just have to convert your inches to miles. So, and you have to have your inches in a decimal format. So I'm not doing that math. So here is your wheel size. That doesn't change. That's the same for slowest or fastest. That's always the same wheel size, unless of course again you change your wheel size or your tire on it, everything. Your maximum RPM, I could only do 128 tops. I'm just gonna put in 120, and that does not change. That's my max RPM. What we do is divide that one by that one, multiply with that one and that one, and we are gonna get a number out of it, and it's gonna be, I'll show you how this works. So 28 divided by 28, let me just fold away this paper here, okay, that's good. 28 divided by 28 is 1, so I'm not gonna enter a 1 into a calculator if you don't mind. The next number is 2.05, and it gets to be multiplied with 120 RPMs. I have a number 246 out of it. That means it's 246. I'm doing 246 meters for every minute. Just visualize it one more time with me here. The crank goes around 120 times a minute, and every turn propels the vehicle forward 2 meters and a little bit. So in that 1 minute I'm gonna cover a total of 246 meters in a total. That's how many meters a minute. To get meters per hour out of it, you're gonna have to times this by 60, because there are 60 minutes in an hour. So you take that number, times it by 60. So I'm gonna go times 60. So I covered that many meters in an hour, and I'm gonna write it. Why do I write it? I'm gonna write it here. 14760 meters are covered in an hour. To get kilometers per hour out of these meters per hour, you just have to divide by 1,000. So that means just take the decimal dot from here and just move it 3 places. 1, 2, 3, there. The final answer is 14.7. Okay, 14.76 kilometers per hour. That's the top speed of my vehicle in the lowest transmission ratio. So what is it when it's in the highest gear? When it's in the highest gear, I counted the teeth again. What was it? It was 48 teeth on the sprocket there, and 13 on the driven one, because that was the biggest at the front, smallest at the rear. This gets divided by that, multiplied by the wheel size, that doesn't change, multiplied by that also doesn't change, multiplied by 60 again, and divide by 1,000. I'm gonna write that one there. Divide by 1,000 again. Let's do this super fast. 48 divided by 13 equals that number. That's my transmission ratio. I'm gonna times it by 2.05, times it by 120, times it by 60, and divide it by 1,000 equals 54.49. You can see 54.49. I'm just gonna write 54.5 kilometers per hour. What this means, again, one last time, is that this is the fastest pace I could pedal this bicycle. That's a given wheel size, it doesn't change. A given front sprocket, a given rear sprocket. Every single time the wheel turns around, my bicycle goes a set distance forward, and in an hour that distance will amount to 54.5 kilometers, given my wheel size doesn't change, and my pedaling speed also has to stay 120. So this way you can compare if you have a bigger wheel or a smaller wheel, or if you change tire, or if you change anything else on the cycle, you can compare the top speed on it. With this calculation, you're not going to be able to assess your friction on bearings or changing a chain, okay? Because this is going to be eating away from this top speed. So you're not gonna, this is a theoretical top speed, you're not gonna reach it on a flat level ground. You're gonna reach maybe, I don't know, 45 out of this one, something like that. But any changes you do to the cassette, it's called a cassette on a bicycle, you change the number of teeth at the front or at the back, or you manipulate the wheel and tire size, you're gonna affect the top speed of your given piece of machinery. So that's the basic calculation. And if you want to speed up, one last idea, this calculation, because this is a constant number here, doesn't change, that one doesn't change, that one doesn't change, and that one doesn't change. You can just multiply all of them together and divide by 1,000, come up with just one number, and just plug in your new front sprocket and rear sprocket teeth number and come up with a different speed, higher or lower, because those numbers don't change. So just leave them together in one subtotal. And it also, just like 5 by 3 by 2 or 2 by 3 by 5, it doesn't matter, the end result doesn't change. The same way, whether you times that one and that one first and divide after, and times that one after, or do it in this order, you'll see it doesn't affect the end result. Just watch out for those sprocket teeth. This division is critical, that this number be the first, that one be the second. In my next video, I'll show you how to deal with a gearbox and how the gearbox works in a similar arrangement similar to this.